Thank you, Mason. Really cool panel. We're going to kind of switch gears here to delve into the fascinating topic that's really pushing the boundaries of human innovation. Space architecture, spotlighting some of the innovative programs and infrastructure right here in Arizona. And we have actually two coordinators, Elena, Rocchi, and Trotti. If the moderators could come on up and introduce their panel. Thank you.
Welcome to our panel, Space Architecture Designing for Permanent Habitation. I am on orbital and lunar station. I am Dr. Elena Rocchi. I'm a professor in the design school and a head of space architecture and extreme environments. And I was touched by what Mayor Gallego called the magic of space. And so I started to lead an education initiative for exploring how architecture and design supports human life in space and extreme condition. And together with space architect Guillermo Trotti, we created a master program to connect actually ASU three major space initiatives, as highlighted by Sally Morton this morning, ASU New Space, the Milo Institute, and of course, the Interplanetary Initiative. And as General Warden highlighted this morning, Arizona leads in space innovation, biotech, agriculture, and resource utilization. And for us, the architects, the designers, these are all vital for sustaining life on Moon and Mars. And so space architecture ensures that these settlements, the one that are actually always on top of us, are not just possible, but livable. And so I'm very honored today to introduce a distinguished group of thought leaders. We are working together actually since now a year, and they will share with us some thoughts about how we think as in design and in the future, how to shape the future of space habitation. I have Guillermo Trotti here. He's the co-founder of the master here at ASU, and he's a visionary architecture specialized in extreme environments, including NASA, Mars, and lunar-based projects. I have Chris Maender. He's a senior executive at Barrios Technology and a commercial space leader. He's driving the transition from isolated outposts to thriving space communities. I have Dava Newman, the director of the MIT Media Lab and Apollo Program Professor of Astronautics at MIT, and she's very renowned for one of my favorite design, the Bios suit. And I have Kay Staats, the director of the Research for Space Analog for the Moon and Mars, SAM, and a Biosphere too, at University of Arizona. We're going to work together. He's interested in his bioregeneration expertise for designing life support system of sustainable space habitat. I want to start with you, Guy. Time is running. It's super stressful. For this amazing audience, Guy, tell us, what is space architecture?
Well, good afternoon, everybody. Yeah, I started as an architect, graduating in the 70s, right after Skylab happened. And that's when actually the first designers got involved in space, designing many aspects of Skylab, industrial design work on the galley and fighting for the windows and so on. So that was the first time actually that we've spent any time in space. So now, as we heard, today and mostly this afternoon, the huge change and acceleration that we're having in terms of populations or larger number of people going to space, and the possibility of having tourists in space. We already have them. How that might grow. We have companies building maybe a new space station for just that, or going to low Earth orbit for that, as well as all the research that is going on in the space station and the ISS for the last 20 years. place where I spent, pretty much my whole life, all the way from the early development of the space stations before the ISS was called that. I started in the 70s as an undergraduate doing a lunar base, then working on, truly the base, how we would build a space station. I had a startup called Space Industries in 1980, where it was the first movement truly from NASA to commercialize space. So there was a great initiative. We started actually building a module for manufacturing in space for medical purposes with Johnson. But we were depending only on one launching system, the shuttle, which it proved to be not as reliable as we wished. That was a short-lived part of commercialization in space. We turned the company into doing satellites and other things. But this is a totally different era. And this is so exciting for me to be part of it, to be here for it, and actually going to the moon. Now that we're building landers on the moon, all the different vehicles that we have of all different sizes, not only in the United States, whether it's SpaceX or Blue Origin, but all around, truly almost every country right now has some sort of rocket to deliver items to low Earth orbit. So it's an incredible time, and it was very exciting to see David and Pete discuss, all this incredible companies and future that we have, and near future, and the acceleration of this future. So space architecture is to really house all these, new spacefarers that we will have. So we will have not only astronauts, highly trained people, but we will have people like you and me, people that might want to go to space for short periods of time, or all the companies that we're talking about here, the possible companies that might need a laboratory, might need a type of tools in space to do their experiments, to develop their products, materials, whatever it may be. But it's for certain that we will have more and more people going to space. So these new people are not going to be the astronauts, the superheroes that we have had until now. They really are going to need way more amenities than what NASA for sure doesn't provide to their astronauts, and very Spartan environments. So this new program of space architecture is really dealing with these issues, not only the structural elements, how we might build larger structures in space, in orbit, as well as how we might build on the moon. Specifically, we're focusing on now how we might build and use the lunar environment to build new facilities there, eventually to launch to Mars. So in a nutshell, we're creating, having more and more architects and designers that will take care of the design of that environment.
Oh, yeah. Thank you. And at the end, in design, we always say that all of us, we never notice, but the first things we see and the last things we see is a ceiling. So what is going to be the ceiling on space? Talking about future, Chris, what is your view on the future of commercial ventures on LEO or on the moon?
Excuse me. First off, the desert is sucking all the Houston, Texas humidity out of my body right now. So if I have to clear my throat, I'm sorry. I come at space from a different place. I come at space from a user, in the sense that my whole career has been around using space and using the microgravity environment for applications, including research and technology development, and now things like in-space manufacturing. I consider myself an exploration dreamer, but also an exploration realist. And what I mean by that is I'm extremely hopeful about moving humanity off the planet, but I don't think you can do it without a sustainable backbone in space. And I don't think you have a sustainable backbone in space unless you have reasons to put humans in space. You can call the reason to explore a reason to put humans in space, but it is not enough of a driver to sustain the economics of the cost of doing it. And so you have to find real things that you can do in orbit real things you can do on a lunar surface that drive value, as we heard about in the last talk. And that value needs to drive money. And that money and profit is what drives the reason for people to put more things into space to support all the humans. And it's that sustainable infrastructure, and I liken it to maybe the development of this campus over time. I've heard, it's my first trip to Tempe, I've heard about what this campus looked like 30 years ago and what it looks like today. When you talk about space, you need to think about it not in terms of the trailers that you first put in place, to the buildings that you then build, and then the stuff that you move into those buildings, but you need to talk about the hospitals and the cafes that you build around all of this infrastructure to care for the people that care for those buildings and care for the work that's going on inside of them. And it sounds a little bit far-fetched, perhaps, but I think that's the reality that we need to think about in terms of the market we need to build. We need to find those sustainable users of space. It's what I'm actually dedicating the rest of my career to, is looking for those uses. And the reason I think that is because once you build the reasons to have people in the space, and once you build the infrastructure to house and care for all those humans in space, who, by the way, are super fragile creatures when it comes to space, you suddenly have a new jumping off point for exploration. And when you can do that, when you can launch missions and expeditions not from, let's say, the surface of Earth, but you can launch them from a layer of infrastructure in low Earth orbit, you change the paradigm in what you can do. We heard in the last talk that they talked about the doubts that maybe exist in terms of what you can do with a space environment, what you can create, what you can do. But I do think, based on all the work that I've done as a founder of Axiom Space over the years, that there are a number of different applications that drive value for platform providers, and especially drive value for human spaceflight. Especially in the world of in-space manufacturing and industrialized research opportunities, using space as a unique environment to do things that you can't do on Earth. And why that's important is because at the end of the day, it drives unique designs that have to go into space. And this comes back to why I'm on this panel. When we talk about the needs of space, when you get beyond the habitats and you start talking about what it takes to build the hospital, build the cafe, build the cafeteria to care for humans, when you talk about what it takes to build the R&D research lab or the clean lab for the semiconductor industry that you're now making new materials into space, suddenly you need an entire army of new architects and new industrial designers, people who understand the space environment and can translate those terrestrial designs into celestial designs that ultimately help drive that innovation in space and that profit-making in space. And all of that requires talent. And so it's exciting to be in on the ground floor at what's going on here, because what I see happening is within Arizona, this ecosystem is really flourishing. The question I've had for all of the folks that I've talked to today is going to be, what can Arizona do to foster that, what I would call non-traditional space, pushing space into the other areas of industry that are so successful in this state. How is Arizona going to do that, and how is the educational system, how is ASU and University of Arizona, how are we going to push that out? So that's the perspective I bring for now.
Thank you, and thank you for speaking of celestial design. I think I'm going to brand it, but Dava, thinking in terms of this reality of things that Chris is referring to, and those celestial designs that we craft for our fragility, what technologies need to be developed or tested on the moon before we head on human Mars mission?
Thank you. It's a pleasure to be here. Hi, everyone. Exploration, first of all. I'm an explorer. Are we alone? Are there other habitable planets? And when will we find life? Those are the three fundamental questions that hopefully make an arc about everything that's been said today. I mean, that's the inspiration. That's where we're at. So let's talk a little bit about Moon and Mars. Earth, spaceship Earth, my favorite planet, I just have to start with. But we're here. Congrats to the Firefly team. I think they get a round of applause. This is amazing. Private company, Blue Ghost. Really, really amazing. There's nothing like getting to the moon. I am the Apollo program professor, so it's taken 5 decades, but we're there. We're on it. and the commercial lunar programs. So we put those together when I had the pleasure to be NASA Deputy Administrator, the public-private partnerships. This is a long investment. Guy talked about the early space companies 3 decades ago. Now there's no turning back. We've hit that tipping point. This is my lunar mission control team. We were on the IM-2 mission. We picked IM-2, don't pick IM-1. Tipped over again. Really want to give them an altimeter. But our 3 payloads, our science, we have a depth camera, and we'll fly again. I don't know if you know, but I gave the failure award at NASA. I instituted the Fail Smart Award. I did not want to share it with my team and my students for the IM2. But you get up, you do it again. You do the hard things. You do the hard things because that's how inspiring it is. We go around the world, we do analog missions, we do simulations. So we have a great lunar simulation. The mission was supposed to work like this. We're going to the South Pole. The South Pole's crazy hard. Do the hard things. Nokia had the antennas, the communication on board. We had rovers. Roll out those rollers, international, one from Japan, one from Lunar Outpost. Our payloads, the depth camera, a little Astra Ant there. Again, fundamental science. We don't have depth perception. You need superhumans when you go explore the moon if you don't know that. Our eyes aren't good enough. You don't know if it's 10 meters or 100 meters away. So we got to build that into the suits of the future. Give all these kind of superhuman capabilities. And humans. Democratization of space is a real thing. It's a real thing. My students put 1,000 voices there, 65 different language. What's it mean? What does space mean for you? Kids all over the world, explorers all over the world, because we're all in for space. So developing tools, developing technology, and making sure that everyone knows that this is for them. There's a tipped over craft. Earth is just always beautiful. No matter when you look, remember that that's the best planet. We have high resolution, real high resolution from LRO. That's kind of the crashed or tip landing, if you will. Well, we'll do it again. We'll do it again. So all this technology development, it is, in my mind, to go forward. Humanity is becoming interplanetary, absolutely. Guy's rover, the GT Scorpion on the left. We're real fans of mobile, not bases everywhere. I do like lava tubes, I have to say. But let's go explore. Let's roam around. We're scientists, engineers, designers. That's why I'm glad to join this planet. We are going to have a lot of fun. When we get to the moon, you are Superwoman. 6 to 7 times higher than you can jump on gravity. Gravity just holds us down here. Get to Mars, you can jump 4 to 5 times higher. So I love designing and developing and looking at these. I'm going to show you a quick video of the technology in terms of suits, life supports that we're taking a look at for the future. I think we need new technology, all life support systems. So this is just a quick, our latest prototype actually is mechanical counterpressure. This is 3D knitting. People thought we were crazy when we said we're going to shrink wrap our astronauts. They still think we're crazy. That's all right. We're just working on the technology. So everyone needs their own suit. It's basically an engineering, marvel to take a suit, all the life support systems, shrink it around a person. But what we forgot in all of our current suits in the last 50 years is that wastes all your energy and it limits mobility. So the flip side, we just we kind of flip the design. See the black? You'll see the black in that suit right there. It's a brand new material. It's carbon-doped polyethylene. Gives you thermal protection, gives you partial radiation protection. But what I care about is mobility and kind of astronauts that are kind of superhumans for the future. So we embed a lot of technology in here, but mostly lightweight, order of magnitude less cost, lots of mobility. That's the future of getting people off this planet to the moon and to the Mars. So a quick preview in that, and I want to pass it on.
Yeah, and thank you. Yeah, applause. And thank you for the beauty of the images. This panel, probably when we were submitting slides, they told us, no one is doing it. I said, but we want to do it. And thank you, Dava and Kai, for sharing the beauty of these images. They are created by you to blend, in fact, all this functionality and technology and innovation with creativity, which is something that we need to sit at the table. Kai, how does looking to a future on the moon and Mars benefit our life on Earth today, which is a fundamental question even in our program?
Thank you. It's an honor to be here. Kai Staats, Director of Research at Biosphere 2 for SAM. And I'm going to tell you a brief story, starting with this entire journey that I'm on, started in 2017 right here at ASU at the Interplanetary Initiative. I was fortunate enough to be funded and one of the very first, the first 12 folks in the cohort, and just took it off from there. So we started with a mathematical model, which I'll talk about in a moment, and I'm now at Biosphere 2. My team has, in the last 4 years, physically built a hermetically sealed and fully functional pressurized Mars habitat analog. So I'd like to start with this image, which was produced by my good friend and colleague, Ryan Vierstig, because it invokes, for what a lot of us grew up with, a sense of awe and passion and mystery for what it might be to be interplanetary. It's a fictitious drawing, but it represents something that we might achieve someday. Okay. This, however, is what happens behind the scenes. Most science fiction films do not show us eating. That does not show us cooking. It does not show us using the bathroom. It does not show us doing all the things. I think there's a few. I can name 3 science fiction films that actually show people eating. So this is a mass flow diagram, and this is from Lunar Palace, which was a highly successful enclosed, 8-month enclosed environment built by the Chinese at I apologize, I forget the name of the university. But this is a really good brief description of what happens behind the scenes. What are we going to deal? How are we going to deal with our urine, with our feces, with condensates, with the plants and the portion of the plants that we don't eat, otherwise referred to as inedible biomass? So these are things we take for granted on planet Earth because we have a large, well, what has felt until the Industrial Revolution like a large, almost unlimited resource, and now we know that's not true. When you're locked inside of a small vessel, your habitat is extremely small. Every breath you take, every drink of water you consume immediately affects your environment. And this is a zoomed-in version. Chris, this is for you. This is what I built in 2017. It took 6 months to build this diagram. And this is the beginning, just a first look at what's called mass flow. It's a movement of electricity and heat and phosphorus and nitrogen and potassium and all the things, and the metals, all the things that are required to actually build a facility. This is the full diagram. So I took that first diagram, actually it was the one on the left that I started with, enhanced that with the one from Lunar Palace, and then I built this. And this is what we built a mathematical model around and a graphical interface, a graphical web interface, which was funded by National Geographic Society for 4 years and is now open source and available to everyone in the world on a free website. So we have citizen scientists, kids all over the world, kids meaning grades 5 all the way through 105 years old. We have kids who want to know what it would be like to actually live on Mars. Well, they get to design, I think that's the next slide. Yes, they get to design their own Mars habitat. They choose their plants, how many square meters of each plant. They choose their solar panels, their batteries, how many astronauts, how much water, how many rations they want to bring with them. This is a model built on real, authentic NASA data. It's 40 years of data that comes out of Ray Wheeler's work and a number of university professors, coupled with the baseline values and assumptions document, which is the Bible for all NASA work on humans. I'm sure you're well familiar with that. And then you set this model in motion, and you determine whether or not your astronauts live or die. And it's a lot of fun. It's very educational. Yes. And so this is Cornerstone. Now, following my work at Arizona State University, 2017, 2019, in 2020, during COVID, I was writing proposals to raise money. And I was successful on my 11th proposal, and after a lot of begging and pleading and a midnight letter to the guy who said no, the next day he said yes, and I was able to raise a significant amount of funds to build this. So this is at the Biosphere 2. It's built around the 1987 prototype for the Biosphere 2 called the test module. This was built by the Biospherians before they built Biosphere 2. They took turns living inside up to 3 weeks at a time, completely sealed from the outside world, living only all their oxygen produced, all their carbon dioxide sequestered, even their human feces processed by plants inside. So this building had been abandoned for 25 years. We took this building, refurbished it, got it pressurized again, added on a sealed engineering bay and a crew quarters. And the final scene, this is the inside. So this is our hydroponics, now inside the original test module. So we've moved from earth-based or soil-based systems into hydroponic systems. Everything we've done with our own hands. We've had 3 contractors. I will never hire a contractor again. We do everything. My apology to any contractors in the room. We do everything ourselves, and we do it right, and we do it fast, and we do it inexpensive. So these are home design hydroponic systems, and we're now entering phase 2 of a 2-year PhD project, my PhD student Attila, in which we'll be demonstrating the transition from physical-chemical to bioregenerative life support. And nobody's done that in one facility before in one mission. And this is our recent addition. You like lava tubes? We have a lava tube. So this is I have just one photograph of this. It's a gorgeous facility. This is a geologically accurate, the largest geologically accurate indoor Mars yard in the world. This was constructed by a top-notch Hollywood team that came out and built all of this. There's a whole bunch more, 3,000 square feet. They built it in 15 days. And so my team put down the backdrops and bolted all the plywood, and then they came in. We had styrofoam blocks. They sculpted this with chainsaws and gardening tools and hot knives, sprayed concrete on it, and this is a representation of what would be thousands of kilometers of Mars habitat condensed into a single room, so that when you leave our facility, if you're sealed inside in a mission, you leave our facility in a spacesuit that's fully functional. We hope one day it'll be one of yours. And you're on an umbilical cord, breathing the air from inside. You are now exploring what looks and feels as though you're on Mars to enhance that experience, both for science and for the personal experience.
I have been there, and actually I become that kid of the future that you're mentioning. So thank you so much. We have 2 minutes left. I wonder if you want to go with the last question. You want to open the question to the public? What do you prefer?
Can we stay a bit longer, just for people who want to stay in our?
I don't think so.
10 minutes?
I don't like.
Go. Okay.
Education of the future is our final question, and we can do a rapid round.
Yeah, I do, because I do have a question, and we are talking a lot about that because I'm an educator, and I think the reason why I left my beloved Rome and after my beloved Barcelona to join this climate that you're experiencing, Chris, is because I believe in ASU mission and charter. I believe that we provide a comprehensive education to all, and that's why I'm here. But in general, for all of you, where is the future of space education? Guy, or anyone. We have
Okay.
1 minute and
I can
28
start. Okay,
seconds.
quick. In my personal experience, space sciences, and probably because of the incredible foundation in science fiction books and movies, it gets people excited about things they'd otherwise be scared of. I can't tell you the number of times people say, I'm not good at math, I don't like science. Oh, but I like going to Mars. Well, if you're going to go to Mars, you have to have math, you have to have science, and suddenly it becomes exciting. And every school group that comes through, and I've had thousands of people come through our facility, I hit them with math, I make them do the math on the spot, and they're excited about it because they recognize they have to be able to count molecules, count liters of water, they have to be able to do basic arithmetic and algebra, and suddenly it's easy because it's tangible, it's exciting, and they see themselves going here.
Yeah, and my short one is the same, but it's STEAMed. You know, I'm trying to lift up STEM. My entire career is bent to do that. But you have to bring in the artists, the visionaries, the architects, because you paint the pictures, you tell the future. You know, you're the storytellers. I'm there to do the technology, and the designers are needed. We have, you know, a whole new generation of 3D makers. So, you know, we just have to revamp all of education. We have, you know, medieval academic institutions, and ASU is a great example to say, no, we don't need siloed things. We need to go across. We do multidisciplinary. I'm at the Media Lab, you know, it's art, design, engineering, and science. So you don't have to be the best in math and physics and science. I wasn't, but I use them every day. You know, those are our tools. AI, you have got to use AI as a tool. It has to be responsible, ethical, test it, you know, question, you know, back it up. And is it for you? Does it represent everyone in this room? Okay, then it works. Then it works. So we have a lot of work to do. Space isn't that special anymore, low Earth orbit. I think it'll be the first billion-dollar drug, the first pharmaceutical. Maybe the business case closes for low Earth orbit. You know, Moon and Mars, let's talk about it at the break. I haven't seen the business case close yet, but I just can't wait till low Earth orbit. So, you know, space is just the extension. Oceans, our most precious ecosystem, Earth, you know, air, and all the way to space. This is just, you know, the holistic view of that's humanity. That's where we are. Let's take care of it. But again, it should be for everyone. And we're lucky because we got the best card going. We don't have to do any market analysis. Everyone's excited about space, so we just have to convince all of our students and the young people that yes, this is for you. You can contribute. You know, you belong here.
Yeah, I would add just 2 quick things. Interdisciplinary influence on other degrees at the university level, things like the initiative is doing, are super important to make sure that traditional industries and folks wanting to go into traditional industry need to understand space if they're going to be successful in their careers in the future. And then you need to see that push down to the grade school level where every child understands that space is involved in every kind of thing that they might want to do. And furthermore, that everything that they might kind of want to do is going to be involved in space. And when someone who's interested in arguing learns that they want to be a lawyer and they understand they can be a lawyer in space, then that's a powerful thing.
Well, yeah, in terms of spaces, we need everybody, just like Dava just said. It's not just engineers and scientists and so on. We really need everybody in space, and I think that's the great thing about being here at ASU, the broadness of the space initiative, the Interplanetary initiative. Really almost every school within this university has some aspect of space, and that's what fascinates me. It's not just the technical aspects, as we started at SIXA, a school in Houston that really focused only on the engineering and the development of spacecraft and for space, but actually here we look at societal issues, political issues, economic issues, and so on. So this is an incredible environment for education and the growth of the space business. So I'm really glad to be here with all of you.
And thank you, Jessica, for including designers at the table, for propelling the space economy at new heights. I want to say that in space, there is space for all. So thank you so much. Thank you, these amazing panelists, for your time. Thank you.